Approximately 93 million miles, or 150 million kilometers from the Earth, lies our nearest star, the Sun. The Sun is responsible for life as we know it, and for the entire solar system. But the Sun doesn't just provide light and heat. It also constantly affects the planets and solar systems in ways that most people don't realize. Learn more about the Sun, its past, present, and future on this episode of Everything Everywhere Daily. This episode is sponsored by ButcherBox. The holiday season is approaching, which means sharing meals with friends and family. If you're planning a meal for the holidays, you're going to want to get the finest meats, poultry, and seafood, and that is where ButcherBox comes in. ButcherBox offers only 100% grass-fed and grass-finished beef, crate-free pork, organic free-range chicken, and wild-caught seafood. But if you're interested in something a bit more traditional, at least for Americans, they also have something that you and your family might want for the holidays: turkey. You can serve some of the best free-range turkey with no added antibiotics, hormones, or preservatives. And if you're looking for turkey for your holiday meal, you're in luck. ButcherBox is offering Everything Everywhere Daily listeners free turkey in your first box, plus $20 off your first order. Just sign up at butcherbox.com/daily and use code DAILY. Once again, butcherbox.com/daily, code DAILY. This episode is sponsored by BetterHelp. Are you feeling overwhelmed by the challenges of life? Do you wish you had someone you could talk to who could provide guidance and support? Maybe you're struggling with anxiety, depression, or relationship issues. Perhaps you're dealing with stress from work or school, or you simply want to prioritize your mental well-being. BetterHelp's team of experienced therapists can provide the support you need to navigate life's challenges. BetterHelp is all about making professional counseling accessible, convenient, and affordable. With BetterHelp, you can connect with a licensed therapist from the comfort of your own home via online video sessions, chat, or phone calls. No matter where you are or what you're going through, BetterHelp is there for you. Just fill out a brief questionnaire to get matched with a licensed therapist, and you can switch therapists at any time for no additional charge. Everything Everywhere Daily listeners will get 10% off your first month with BetterHelp. Just visit betterhelp.com/everywhere to get 10% off your first month. That's BetterHelp, HELP.com/everywhere. A trick question that people like to ask, and maybe you've heard it, is what star is nearest to the planet Earth? If they know a little bit about astronomy, they may say something like Proxima Centauri. But of course, the answer is the Sun. The Sun is literally and figuratively the center of the solar system. Without the Sun, there would be no solar system, and there would be no Earth. I'll start by giving you a perspective on just how big the Sun is. The Sun is gargantuan compared to the Earth. Approximately 1 million Earths could fit inside the Sun if it was a hollow sphere. The diameter of the Sun is 1.39 million kilometers, or 864,000 miles. Whereas the Earth only has a diameter of 12,700 kilometers, or 7,900 miles. The solar system is often thought of as the Sun, the planets, and all the other debris that's floating around the Sun. In terms of mass, however, the solar system is really just the Sun. The Sun comprises 99.86% of all of the mass in the solar system. The Sun is approximately 4.6 billion years old, only a few 100 million years older than the Earth itself and other planets in the solar system. The Sun was formed out of a molecular nebula mostly consisting of hydrogen and some helium. However, there are also some heavier elements that had to have come from previous stars which exploded. As the cloud of hydrogen began to coalesce due to gravity, the pressure within the cloud eventually became so great that fusion began to occur with the hydrogen atoms, which began giving off an enormous amount of energy, turning that cloud into a star. I've gone through the process of how stars are formed in a previous episode, so I won't belabor the point here. By mass, the Sun currently consists of 74.9% hydrogen, 23.8% helium, and under 2% all other heavier elements combined. The Sun is classified as a G-type main sequence star, also known as a yellow dwarf. It's larger than 85% of the stars in our galaxy, most of which are red dwarfs, However, there are stars much larger than the Sun. The star Betelgeuse, for example, is over 1 billion times larger than our Sun by volume. These giant stars don't have long lifespans, which is why there are so many smaller stars. It's believed that the Sun is roughly in the middle of its life and will continue to burn for another 5 billion years. In 5 billion years, the hydrogen in the Sun will have been exhausted and it will enter a new phase. The core of the Sun will contract, increasing its luminosity and increasing the overall volume of the Sun to become a red giant, engulfing Mercury and Venus and probably even Earth. It doesn't have enough mass to explode into a supernova. Instead, it will eventually settle into a white dwarf, which is pretty much what it will remain for the rest of its life. The Sun is obviously the brightest thing in the sky. It is actually 13 billion times brighter than the next brightest star, Sirius. So don't look directly at the Sun, but you can look directly at Sirius. Light from the Sun takes approximately 8 minutes and 20 seconds to reach the Earth. Depending on the time of year and where the Earth is in its orbit, that can vary by as much as 2 seconds. The Sun, in addition to obviously being bright, is extremely hot. However, the temperature of the Sun can vary greatly depending on where in the Sun. The core of the Sun is believed to have a temperature reaching about 5.7 million Kelvin or 27 million degrees Fahrenheit. The core of the Sun is where most of the fusion takes place. The temperature then drops down to a balmy 5,800 Kelvin or 10,000 degrees Fahrenheit on what is known as the photosphere of the Sun, which is the visible surface. However, above that, in what is known as the corona, the temperature jumps to an average of 1 to 2 million Kelvin. And there are some regions within the corona that can get as hot as 20 million Kelvin, even hotter than the core of the Sun. The extreme heat in these upper regions is one of the reasons why it's hard to send probes to explore the Sun up close. Any probe needs an incredible amount of shielding. However, shielding is only half the story. Many people will often say that we should shoot dangerous chemicals or radioactive waste into the Sun. The problem is, that is really difficult to do. You would think that with the incredible gravitational pull of the Sun, it would be easy to just drop things into it. Unfortunately, that is not how it works. The Earth is traveling around the Sun at a speed of 30 kilometers per second, or around 65,000 miles per hour. To launch something out of the solar system, it would require reaching a speed of 11 kilometers per second, or 25,000 miles per hour, in the direction that the Earth is traveling. So to put something into the Sun, we would have to get a rocket to a speed to negate the speed of the Earth, which would be twice the speed of the fastest probe we have ever launched out of the solar system. Paradoxically, it would be easier to launch something into the Sun from Mars or any of the outer planets simply because they orbit the Sun slower than the Earth. Instead of worrying about launching things into the Sun, a greater concern should be what the Sun is launching at us. Which brings me to the topic of the solar wind. The Sun constantly emits a stream of charged particles in almost every direction, known as the solar wind. These small particles mostly consist of protons and electrons. Another word for energetic elementary particles is radiation. We had no idea there was such a thing as solar wind until the 19th century. It was first hypothesized by Richard Carrington in 1859. The Carrington event, on which I've done a previous episode, was named after him. One of the reasons why we never noticed it is because the Earth is largely protected from the solar wind by its magnetic field. The solar wind and its interaction with our magnetic field is responsible for the aurora borealis in the northern hemisphere and the aurora australis in the southern hemisphere. If it wasn't for our magnetic field, life on Earth probably wouldn't exist. It's believed that the lack of a magnetic field on Mars is the reason why it has such a thin atmosphere and why there's no water anymore. If the Earth didn't have a magnetic field, life would cease to exist due to the solar wind. For starters, we would be bombarded nonstop with solar radiation. We can survive this for short periods of time, but over years, centuries, and thousands of years, that would add up. That wouldn't even necessarily be the biggest problem. The real problem would be the solar wind gradually stripping away our entire atmosphere. Once the atmosphere is gone, the water would eventually go with it as it evaporates and is all blown away as well. Solar wind remains a huge problem for interplanetary travel or for bases we might want to put on the Moon or Mars. There are plans for space stations with water or magnetic barriers to block or deflect solar radiation, and plans for moon bases that include building the base underground or in lava tubes. Thankfully, we don't have to worry about the magnetic field of the Earth disappearing for many, many millions of years. While we don't have to worry about the solar wind stripping the Earth of its atmosphere anytime soon, that isn't to say we never have to worry about emissions from the sun. One major threat to our advanced technical civilization is the possibility of a large solar flare. A solar flare is a single large emission from the sun, and it usually results from a large burst on the surface of the sun. The sun has a very powerful magnetic field. The magnetic lines can get extremely twisted sometimes, and when they become too twisted, they can burst, releasing enormous amounts of electromagnetic radiation. A large enough solar flare would cause magnetic storms on Earth, which could short-circuit electronic devices and the entire electrical grid. The last time a major solar flare hit the Earth was in 1859, the previously mentioned Carrington event on which I've done an episode. At the time, there was very little in the way of wiring anywhere in the world, so it mostly just affected the few telegraph lines that existed at the time. If a solar flare of that magnitude hit the Earth today, the effects would be devastating. It could fry most satellites in orbit and could destroy much of what we call the modern world. Thankfully, such events are rare, and when they do happen, they have to be located on the surface of the sun at such a point that they would have to directly target the Earth, which is actually a relatively small target given its relative size and distance. Smaller solar flares occur quite frequently. This has given rise to a new discipline called space weather. Tracking solar flares is key for auroras and knowing how radio waves will propagate in the ionosphere. Another solar phenomenon that is closely related to solar flares are sunspots. Sunspots are sort of the opposite of solar flares. They are dark spots on the sun which are cooler, also due to magnetic activity on the surface. The tracking of solar flares and sunspots led to the discovery of the solar cycle. The solar cycle lasts about 11 years, and it goes from what is known as a solar maximum to a solar minimum. Solar cycles have been tracked and numbered starting with solar cycle number 1 in 1755. Each cycle goes from one solar minimum to the next. As of the time of this recording, we are in solar cycle number 25, which began in December 2019. The solar maximum is scheduled to peak sometime in 2025. But some space weather researchers are now predicting that it actually might happen in 2024. One of the ways we can watch solar weather is via solar telescopes. Given the size, proximity, and brightness of the sun, the problem with a solar telescope isn't gathering light, it's filtering light. Currently, the world's largest solar telescope is the Daniel Inouye Solar Telescope located on Haleakala on the island of Maui. There are also space-based solar probes that observe the sun. Current solar observation probes include the Solar and Heliospheric Observatory by the European Space Agency, NASA's Solar Dynamics Observatory, and NASA's Parker Solar Probe, which will reach its closest point to the sun in 2025. These probes have been able to provide information and details about the sun that were previously unknown. The sun is big, and it's important, and we wouldn't be here without it. However, despite what it might seem, it is not a static thing. It's an incredibly active star that still has the ability to dramatically change life and civilization on this planet. The executive producer of Everything Everywhere Daily is Charles Daniel. The associate producers are Peter Bennett and Cameron Kieffer. Today's review comes from listener S1E Jellyfish Emoji over on Apple Podcasts in the United States. They write, "Amazing podcast. Hey Gary, can I say just how much I love this podcast? It has helped me a ton in school. That calculus episode, for example, was really helpful. I love every episode you put out and hope you keep making episodes, at least until I finish school." Smiley emoji. Thanks, S1E. I hate to break it to you, but your learning doesn't end when you finish school. In fact, it's just beginning. You might not be sitting in a classroom in front of a teacher every day, but you're going to be learning your whole life. Remember, if you leave a review or send me a boostagram, you too can have it read on the show.